From voice agents that are judged on both accuracy and the human feel of a conversation, to quantum circuit synthesis driven by symmetry-aware reinforcement learning, to vision language models, tested on whether they can be remember what they saw across huge contexts. These papers reveal just how fast AI is stretching into new territory. In this episode, we'll connect the dots between evaluation, efficiency, and memory, and ask what it really takes for AI systems to perform reliably in the real world. Let's explore the first paper, EVA Bench, a new end-to-end framework for evaluating voice agents. EVA Bench is a new end-to-end evaluation framework for voice agents that closes two gaps in prior benchmarks: realistic multi-turn audio simulation and voice-specific quality measurement. It runs bot-to-bot conversations over live audio WebSockets with validation-gated simulator checks, then scores each run with two composite metrics, EVA-A for accuracy and EVA-X for experience. EVA-A combines task completion, policy faithfulness, and audio-level speech fidelity, while EVA-X combines conversation progression, conciseness, and turn-taking latency. The benchmark covers 213 scenarios across 3 enterprise domains: airline customer service management, healthcare, HR service delivery, and enterprise IT service management, and evaluates 12 systems, spanning cascade, hybrid, and speech-to-speech architectures. Across those systems, no model exceeds 0.5 on both EVA-A pass at 1 and EVA-X pass at 1. The median pass at K-pass, K-gap, is 0.44 on EVA-A, and controlled accent and noise perturbations produce degradation as large as 0.314, revealing that peak performance substantially overstates deployment reliability. The most important novel finding is that architecture primarily separates experience, not accuracy. Speech-to-speech systems lead on turn-taking, while cascades often suffer from transcription-related task failures, especially on named entities such as confirmation codes and IDs. Let's explore the second paper, Equivariant Reinforcement Learning for Clifford Quantum Circuit Synthesis. This paper reframes Clifford quantum circuit synthesis as a deterministic reinforcement learning problem over 2n times 2n binary symplectic tableaus, where the agent must write multiply by elementary generators hi, s, e, and cz, I, j, until the tableau becomes the identity. The main novelty is a permutation equivariant, size-agnostic neural policy that treats qubit relabeling as an exact symmetry. Tableau blocks are embedded into an n times n grid, aggregated into qubit tokens, refined by shared message passing on the complete qubit graph, and decoded with symmetry-respecting heads for h, s, and cz actions. Training uses PPO with a reverse reduction curriculum built from random walks away from the identity, which scales difficulty from short walks to uniformly random Cliffords. On the 1003 6-qubit benchmarks of Bravey, Shedulin, Hu, and Maslov, the learned policy matches the optimal CZ count on 995 instances, or 99.2%, and gets every instance within 1 CZ gate of optimal after only 21 seconds of policy-guided search. The previous template-based state-of-the-art recovered 982 optima after 217 hours. After continued training on 10-qubit instances, the same policy transfers without reparameterization to unseen Cliffords up to 30 qubits and targets generated from more than 1,000 Clifford gates, where it outperforms Qiskit's Aronson-Gottsman and greedy Clifford synthesizers in average CZ count. An ablation shows that equivariance and qubit-to-qubit communication are both critical. The full model achieves 13.49 mean CZ gates on random 6-qubit targets versus 15.88 for a plain MLP and 15.19 for a flat MLP. Let's explore the third paper, MEMLens Benchmarking Multimodal Long-Term Memory in Large Vision Language Models. MEMLens introduces the first length-controlled benchmark for multimodal long-term memory in large vision language models, evaluating 27 LVLMs and 7 memory-augmented agents on 789 questions across 5 abilities: information, extraction, multi-session reasoning, temporal reasoning, knowledge update, and answer refusal. The benchmark is novel because 80.4% of items contain image-linked evidence, and an image ablation test drops GPT-5 and Gemini 3, 1 Pro, below 2% accuracy, proving the task cannot be solved from text alone. MEMLens standardizes 4 context lengths, from 32K to 256K tokens, using a cross-modal token counting scheme and a needle in a haystack construction pipeline that interleaves evidence sessions with distractor sessions. The strongest frontier model, Quen 3, 5, 122B, A10B, reaches 58.68% overall accuracy at 32K, while Gemini 3, 1 Pro degrades the least among closed models, from 54.1% at 32K to 51.99% at 128K. Memory agents are length stable, but their multimodal compression causes major visual fidelity loss. For example, M2A scores only 15.38% at 32K and remains near 16% at 256K. The hardest capability is multi-session reasoning, where most systems stay below 30%, and Oracle retrieval tests show the bottleneck is retrieval rather than arithmetic or counting itself. The paper's central conclusion is that long context attention and structured multimodal retrieval are complementary, and neither alone solves long-term multimodal memory. That's a wrap on today's AI paper highlights. Thanks for watching.